hope you enjoyed our last video. For this video, we're going to do a brief comparison of the typical approach to teaching and learning math, which is how most of us, including myself, learned math. And then we'll compare that with the Singapore method, the method that we're using here, a method that I think is more natural and has the potential to bear even greater fruit, both for the students who are naturally adept at math and the students who struggle more naturally with math. For both of them, it can help them progress forward and have a deeper understanding. So in the typical approach to teaching math, the teacher gives a procedure and the students replicate that procedure. So we could think of the multiplication algorithm. I stack the two numbers on top of each other, and then I do this number times that number, and then I put the thing up there, I do that number times that number, and then I put a 0, and I cross that out, I do that number times that number, do that number times that number, and then I add them together, and I get an answer. A method that works, a method that's good, a method that's true, but the teacher gives the students one procedure and then says, you have to do it this way, you need to learn to do it this way, follow those steps. So that's the typical way that math is often taught, multiplying two-digit numbers. In our method, we put things in the students' hands, as I said, concrete. We give them something, and we guide them in exploration. We give them an exploration task, and we help them put things together for themselves. Using the place value disk, for example, that I already mentioned, we help them see that when I multiply a 10 by 10, it becomes 100. If I have two 10s and I multiply them by 10, if I have two 1s and I multiply them by 10, they become 200. So if I have 2 multiplied by 10, it becomes 20, etc. So we put things in students' hands and then guide them in a process of exploration, helping them make connections for themselves. And the beauty of that is that one student might figure out a way that works to solve that problem, and another student might figure out a different way that works to solve that problem, but both ways work. And we can encourage them in that and build their confidence that both of them found a way that works. And if one way works great for one student and one way works great for another student, that's great. We want them to be able to solve things in different ways. Right? So we put things in the students' hands and guide them in the process of exploration. And by the way, this is how math was developed and discovered, is people looking at the world and wondering, what pattern do I see? How can I put that together? How can I explain that? Right? So that's how we want to help our students understand math and understand the world. A second major difference, in the typical method, it's usually the teacher doing most of the talking. Right? The teacher is explaining the method, the teacher is explaining the procedure. In our method, we put things in the students' hands, and then we ask them to explain to us what they discovered, to explain to their classmates, and we guide that conversation. But we want students to develop the ability to explain their own thinking. We don't want them to just be rote machines doing a procedure that their teacher taught them, but we want them to be able to explain how they solve a problem, why that way works, and to communicate that clearly to others, especially as they grow. A third significant difference is in the typical method of teaching and learning mathematics, the goal is speed. How quickly can I get to the right answer? And we see this very frequently in our students. You put a question on the board, and immediately they want to give you the answer before you've maybe even asked a question or told them what we're doing. Right? They want to give an answer. In our method, our approach, the emphasis is placed on the process, not the answer. Yes, of course, we want to get correct answers, because math is useful only if you solve it correctly. But we want to place the emphasis on the process and the students understanding how the math works, why it works that way. And that understanding of process will give them greater flexibility in solving different problems different ways, and adaptability to take what they've learned in one scenario and apply it to other scenarios that are similar, and maybe even to build bridges to new concepts that they haven't encountered yet. And we want them to learn various strategies so that in one situation, they can pick out a strategy that is the easiest or perhaps the quickest rather than another. So multiplying, again, coming to multiplying two numbers, rather if I have 32 times 20, rather than stacking them on top of each other and doing the traditional algorithm, I can just look at that and say, oh, that means I need to double my original number and just add a 0 to the end, because 20 doubles and adds one place value. So we want students to develop various strategies and be flexible in using them. Finally, the third major difference between the typical method and our method is, and perhaps this is one of the most significant just in how we approach things. In the typical method, you would learn to solve many problems in one way. That's what you would be doing in class. It's like, we're going to learn this algorithm, and so we're going to do lots and lots of problems with that one way to solve it, so that you can memorize the process and know the steps. But the difficulty there, the problem there, is it doesn't necessarily help you understand why that way works, what's going on, why does this algorithm give you a correct answer. In our approach, we give the students one problem and encourage them to learn to solve it in many ways as they can discover as are possible. And one of those ways might be some of the traditional algorithms or other typical ways that things are taught, but they might find other ways that work as well, and that can help them make the connections between different concepts, between different strategies, approaches, understand, again in this example, why does this work? Why does this give you the right answer? So we want to encourage them to think about understanding and process, not about just following a particular sequence of steps. So those are some of the differences that you might see between the typical method of learning math, again, the way I learned math, the way most of you probably learned math, and the method that we are taking here at St. Constantine, inspired by the Singapore Math curriculum.